hydroxide solution and nickel chloride solution. So to begin, we will go to the container shelf where we can find 50 milliliter beakers. We are going to use 2 of the 50 milliliter beakers and drag them down to the bench. So in the first beaker, I'm going to add 15 milliliters of sodium hydroxide. And I'm going to label both of the beakers to not get the solutions confused. So the sodium hydroxide can be found on the material shelf, and this solution has a molarity of 1, which means that there is 1 mole of sodium hydroxide for every liter of solution. And I will add 15 milliliters. And now the second beaker, I'm going to add nickel chloride solution. And this solution also has a molarity of 1. And I'm going to add 6 milliliters of nickel chloride. Now we can observe both of the solutions, and we can see that the nickel chloride has a green color to it, whereas the sodium hydroxide is clear. So next we are going to add nickel chloride into the sodium hydroxide. We're going to pour all of it in and observe what happens. So now if we zoom in on the combined solution, we can see that the liquid is still clear, but there is now a small green solid at the bottom of the beaker. And if we go to the chemical equation, we can see why this happens. So when researched, I found that when sodium hydroxide and nickel chloride are combined, both aqueous solutions, they form nickel hydroxide, which is a solid, and sodium chloride, which is an aqueous solution, which explains, go back again, this green solid at the bottom of the beaker of the combined solutions. However, this equation that we have here is not balanced, so we'll go to the balanced equation, which shows us that for every 2 moles, 1 mole of nickel hydroxide solid and 2 moles of sodium chloride aqueous solution. So again, 2 moles of the aqueous solution of sodium hydroxide and 1 mole of nickel chloride aqueous solution creates 1 mole of the solid nickel hydroxide and 2 moles of the aqueous solution sodium chloride. So this explains why 2 aqueous solutions created another aqueous solution and a solid. And this was a double displacement problem. And that was the experiment.